we're going to do is that we are going to use what it called the attractor. So the attractor is that another external factor. It could be a curve, it could be a point that our sets of geometry or shape that we create in Grasshopper basically responding to that specific like a attractor point or attractive curve. It could be in different effects on it. With this specific example, the attractor is basically the distance that it has with all like a series of circles that we create. And what we are trying to do in this algorithm, basically, we are trying to add points on different locations and use that point as an attractor, and then adjusting the size of different circles that we have depending on the relationship that they have with that point, the distance that they have to that point. And you can think of this as many examples that you can have in like a real world. Like for example, assuming that you are designing a skylight and you are thinking about a specific like a center or like a place in your building, and you want to parameterize the amount of glass that you have on your skylight, and then using a attractor point, a center point on that specific like a space or room in order to change the size of the patterns of the skylight. So let's get back to creating that algorithm in Grasshopper. So for this, what we need is that we basically need a point as our base point. So we're gonna go with the point, constructing a point. And that point will be on 0, 0, 0, right? It doesn't need to be anywhere else. And then we are going to create a series of number. So I'm going to go here and I'm going to use series to generate a series of number. The starting point, we're going to keep it as is, so we are not changing that. We're going to put it as 0. And then we're going to go saying that the steps will be 2, and the number of the series that we want to generate is going to be 20. So that's going to be the numbers that is going to be generated right there. Now, I know that I want to create a series of points. So I'm going to use the x, unit of x, and unit of y. And the outcome of this series that I generate is going to be connected to this part, so not much different. And then I'm going to use the move, right? And the geometry is going to be my first point, and one of them is going to be, the first one is going to be the let's go back here. This is going to be the series of one direction, and then I know that I want to create a cross-reference of this, and then creating a holistic place to this, and then I'm going to connect the y value to b, and then the geometry to the a value of this. So now I cross-reference them, and I'm using another move again. So here's the move, and then this is going to be my a, and then this is going to be my b. So now I have a grid of points for the center of all those circles. Now all I need is that I have to go back to my object, the geometry, and use the circle. And then this creates a series of circles in the base. If that is bigger than we expected, we can make it a smaller. But for now, we can keep it as is, right? Now that I have the circle, what I need, I'm gonna basically use, I can use the same thing as the geometry as a center point, but I just want to show you another analytic tools that you can use in your Grasshopper. I'm gonna use the area, right? And this can be used for any geometry. For now, we already have the center point, but assume that our shape was different and we want to find the center point of the the shape that we have. We can use the area component for that. So if I connect this, it just generates an area for all those things. And in addition to that, it's just going to give me the center points of all this circle that I have in my grasshopper. Now, let's go back to our Rhino file, and I'm going to actually now go back to Grasshopper. I'm going to create using the points, and I'm going to set one point here. And within the area that I have, I'm just going to go and click in one place. That's going to be my points. Somewhere in that, doesn't matter, we can adjust it, we can move it around, but somewhere in that area. I'm just going to use that. And now what I'm going to do is that I'm going to use the distance. So the distance computes basically the distance between 2 points. I have the center points. That's going to be my first input. And the second input will be the input for the distance. So now I have the distance towards all the points that I have in my grid. So now let's have that distance here. Now what I'm going to do is that I want to create a scale factor based on the distance that I have towards that specific point. So I'm going to create first of all a domain, right? So say it's going to be a domain. We are going to construct the domain, and for that domain, the factor that I want to use is that I don't want it to be completely 0, so it's going to be 0.2, like very small, and then the other like 1 will be 0.85. So the range will be 0.02 and 0.85. That's going to be the range that I'm going to use here. Now that I have my domain, I can go here and then remap the numbers that I have. So the distance is going to be the distance is going to be on the main part. It's the factor that goes into here. So the value that I have. The second one is that is looking for the main like a range of data that we have. The range of data that I have. The distance that I have, it doesn't give me that range. So I need to create basically the boundary between this the bounds, which if you look at the bounds basically get the number, and then the outcome of that, it just tells me that what is going to be the range between these two numbers, right? So the first input for the remap is going to be the source. So I give it the distance, all the numbers, the value. The S is going to be telling the component, the source, what is going to be the range. And what we want to do is that we want to looking for the target, which is between a scale factor that we're looking for, right? So now I have the range that I have generated, and then the main factor, the distance, and then just remap it into a new number, okay? Now, all I need to do right now is that I'm going to scale all this circle based on these new numbers that I generate. So I'm going to go use the scale, and we're all familiar with the scale. The first factor for scale is going to be the geometry itself. So the geometry are those circle that goes into the geometry. We already have the center points, which comes from the center of the area, right? And now we have the factor. So the factor is going to be these numbers. So if I go back here, it's kind of hard to see, so I have to go back here and then turn everything, the preview of everything else that I had before off, so then I can see what is going to be the outcome. So as you can see, the points that are closer to this is kind of getting smaller, and then the points that is farther away, it's getting like a less scale factor. We can directly change the effects, meaning that I can right click here and I just go and reverse it. And if I go back here, you see that it has a different effects on the scale factor that I have on the numbers that I have here. So once I have that, then we're going to use something which is called boundary. boundary is basically getting all the like a periphery of the different curves, or like a line or polyline or spline of like a planar surface, and generate a surface out of it. Like you have like a couple of lines around here, and all of them are planar, and then they make a surface out of it. Right now, I'm just going to use the boundary of surface, and if I open here, you see that it says they create a planar surface out of the collection of like a boundary of that. For us, it's going to be this geometry, this circle. And I'm going to connect it, and you see that now I have a surface instead of like a circle there. So everything looks good. Now what I want to do is that I want to add a little bit of like a color code this as well for myself, to get a sense about which one are closer, which one are far away. So what I'm going to do is that I'm going to use on the parameters, I'm going to use this gradient. So gradient, and I'm placing it here. As you can see, I can open this, I can adjust it. It's very like a self-explanatory in terms of like changing the color, adjusting it, and then the input that goes into there is going to be go to the t value, which is the value of that, and then all I need is that I'm going to use the preview that you used before for the previous assignment, and I'm going to connect this to the material and the surface into the preview. And if I go back here, you see that I have the color-coded formats of all the geometry in that area.